Hello guys, you're welcome to Guide Academy, and in this tutorial we are going to solve a couple of calculus problems as you wait in preparation for your exams. So to go straight to the problems, we are going to solve random problems because the nature of exams is such that you have different types of questions. You don't have it like you have integration section, you don't have the differentiation section and that. So everything is mixed up. So I'll be writing random problems for us to solve. Just take your pen and your book, prepare and also try and solve alongside as we solve some of the problems. If possible, you can pause the video, try to solve the problem on your own. If you get stuck, resume, even though it's live, right? Just for you to test yourself whether you are ready for the upcoming exam. So this whole tutorial is understanding of the fundamentals of calculus, how you are ready for your exams. Thank you for joining in this GAD Academy. This is the first time you have been on this channel. Please do well to subscribe to this channel for more exciting sessions like get your friends gonna be okay. So let's solve this problem. So compute the limit. Compute the limit. So I have a function here, and function is so limit as x approaches positive infinity for the expression 7x minus 4 over the square root of s cubed plus 5. Compute the limit of the expression 7x minus 4 all over the square root of s cubed plus 5. How do you solve this problem? How do you solve this problem? So to solve this problem, you simply have to analyze the point where you want to find the limit. That is one major important thing to do. That always first check the point you want to find. Is it where x is approaching or any particular number? In our situation, you're looking at where x approaches positive infinity. Positive infinity. So let's see how we can solve this problem. But before then, maybe you can try it on your own. As I said, try computing the limit on your own and see if there's something close to the answer, or better still, even the answer itself. Okay, so whenever you have expressions like this and you want to find the limit as x approaches infinity, you mostly use division by the highest degree of x. By the highest degree of x. That is one thing you should take note of. We use the highest degree of x to make this division. And after we put in the infinities and we are good to go. How's that? Okay. So to solve this problem, so as I said, you always have to divide by the highest power of x, okay? By the highest power of x. The question is, what is the highest power of x here? The power of x up here is 1. And the power of x here, don't tell me it is 3. No, it is not 3. It is under the under the shelter of what? A square root sign. So if you want to find the actual degree of a polynomial within a radical function, we just say that if you have f of x inside a square root sign like this, right? So the power is going to be f of x, the power 1 over n, whether it is third root or something. So I want to say that if you have the square root of x cubed, then the degree of x is x to the power 3 out of 2, not 3. So the question now is, we have x to the power 3 out of 2 and we have x. Which one is the highest power? So you realize that the highest power is what? Is x to the power 3 out of 2. So having that in mind, then it means I'm going to divide through my numerator and my denominator by what? By x to the power 3 out of 2. At the end, I wouldn't have done anything. I wouldn't have done anything. So I'll simply have my 7x divided by x to the power 3 out of 2 minus 4 divided by x to the power 3 out of 2, right? All over. Now, when you come inside here, you have square root of x cubed plus 5. Remember that x to the power 3 out of 2 is the same as square root of what? S cubed, right? So it's the same as dividing this by square root of s cubed. So once the s cube enters what I have here, I can have so my numerator, you can see that when I simplify, I have the power of x here 1, the power here to be what, 3 out of 2, right? That's 1.5. So I'm going to have negative half. So I'll have 7x to the power negative half minus 4x to the power negative 3 out of 2. That is for this expression. All over. Then I'll open my square root wide. And here I'm going to have s cube over s cube plus 5 over s cube. Everything is under this one square root. Please take note that the x to the power 3 out of 2, even though it's 3 out of 2, once you are entering the square root sign, the 2 go away, get your s cube back. So realize that this will cancel and get 1, right? So our final expression will then be 7x to the power negative half minus 4x to the power negative 3 out of 2, right? All over square root of 1 plus 5x to the power negative 3. So once you have this done, the next thing is just put in your limit value. Whenever you are talking about indeterminate limit forms, like limit approaching infinity, negative, positive infinity, the rule is that if I have a finite number, say L, over an infinite number, I'm supposed to get 0. This is something you should have it in mind before you do indefinite limit, okay? Sorry, indeterminate limit or indefinite, or I'll say. So here, you would have to know that any number over infinity is 0, aside the indeterminate situation. Yes, I think I confused you guys. So for indeterminate situation is infinity over infinity. You can't tell me infinity over infinity is 1, right? And also infinity over 0. So what you say is any number over infinity is 0, and that is what we are interested in for this particular problem. So when I come here, wherever I see x, I'm going to put infinity there, right? So I'll simply have 7 multiplying, it's positive infinity, so positive infinity to the power negative half, right? Minus 4x to the power negative 3 out of 2. Oh no. So I'll have 4 multiplying positive to the power negative 3 out of 2, right? All over the square root of 1 plus 5 multiplying positive infinity to the power negative 3. So remember that if you have a negative power, you're going to have a fraction with your infinity sign going down, obviously, right? It's like this. You're going to have 1 over square root of infinity give you 0. So at the end, you are going to get this whole expression becoming 0 minus this whole expression becoming 0 all over half square root of 1. This is 1. This also becomes 0 plus 0. So 0 over square root of 1, and the answer is 0. So the answer for our limit form here is what? Is simply 0. If you have any question on this, you can simply type that in the comment section. And also, please do well to solve along the goal. Very important. Let's solve the second problem. I'm not going to give limits, so I want to change this problem. I'm going to give you an exciting problem here, absolute value problem. So I want you to count this for me. 4 minus x is greater than or equal to absolute of 5x plus 1. So you've done the absolute value theorem. You did the absolute problem. You are supposed to be able to you're supposed to solve this. So I have 4 minus x greater than or equal to the absolute of 5x plus 1. How do I solve this? How do I solve this? So absolute value problems are very interesting because of the fact that any number coming out of this absolute sign here should be positive, right? So there are two outcomes for every situation. Now, whenever you are solving for absolute value problems, we use cases. So case one obviously is going to represent a situation where you have a positive scenario. You have when you have a negative one. Now, the term that is within this absolute value signs is what you're going to look at first, because 5x plus 1 may be positive or negative. Mathematically, if you say 5x plus 1 is positive, that is greater than what 0, right? It's greater than, or yeah, positive means greater than 0. So whenever you are solving an absolute value problem like this, the first thing to do is simply to take the part which is inside the absolute sign. Here you see it's on only one part, right? Yes, so that's what you're supposed to do. Then that will give us the two case scenarios. For each case, this being positive in the first case, you have to solve it being positive. So just it being positive, you have to solve it. So therefore, you realize that you are going to get x to be greater than negative 5. That is clear here. And you know that if this is positive, then our entire absolute value problem becomes 4 minus x greater than or equal to 5x plus 1. You get it? But the first start is the case test. Case testing gives us one limit, or it gives us a solution to our limit. For this to be positive, 5x plus 1 should be greater than 0. Therefore, x is going to be greater than negative 1 out of 5. Then, for the entire thing here, the first case scenario where this is positive, I'll have 4 minus x greater than or equal to 5x plus 1. So here I'll end up getting, I'll push my 1 there, I'll have 3 greater than or equal to, I'll push it, I have 6x, right? I have x to be less than or equal to 1 out of 2. So you can see that x is greater than this, and so case 1 gave us an absolute equation which is inequality. So I'll have s greater than negative 1 out of 5, less than or equal to 1 out of, like this. Put it down. Case 2. For case 2, then it means that 5x plus 1 should be greater than what? No, should be less than 0. If 5x plus 1 should be less than 0, you're going to have x to be less than negative 1 out of 5. Put this case down. And the next one is you're going to have 4 minus x to be greater than or equal to negative of this expression. Take note, we are looking at a case where 5x plus 1 here is negative. So we are going to have negative of the entire thing. Negative 5x, negative 1. Then what I do is I'll push this here. I'm going to get 4x. I push this here. I'm going to get negative 5. Then I make x greater than or equal to negative 5 on 4. That is one of my solution value. The next is, since we've chosen the case scenario where 5x plus 1 is negative, I would have to solve 4 minus x. I think I did that. Oh, sorry, I've got to my value. So therefore, let's write our point. So our point then becomes from x is less than this, negative 5 out of 4, less than x, less than negative 1 out of. Therefore, we have gotten separate inequality bound. The next thing to do is what we call merging. Have to So to merge the two, what do? Simply have to take common endpoint. Now, assuming that you have a range, and the range is saying that x is greater than 3, another range is saying that s is greater than 2, you realize that it is better I choose s greater than 3, because if something is greater than 3, obviously it will be greater than 2. Likewise, on the negative side, if something is less than 1, something is less than 0, realize that if I say something is less than, obviously that thing will be less than 1. So in merging inequality ranges, choose the highest positive number, choose the lowest negative number on each other ends. So when I come negative 1 over 5, negative 5 out of 4, which will negatively polar, right? That is this, negatively polar. So I'll have my negative 5 out of 4 being smaller than the selected. Negative 5 out of 4 will have 1 out of 2 is far bigger, right? So if something is less than or equal to this, it also be less than or equal, choose bigger one or answer. So that is the end of the second problem. I'm going to give you the third problem. Let's do some exciting problem. Okay, now let's a bit word problem. It says that a cylinder, a cylindrical can. So a cylindrical can, cylindrical is to be made hold thousands a cube of oil. Find dimension that will minimize. Find a dimension that will minimize cost of the metal manufacture the can. So let's analyze this problem. It says that a cylindrical can is to be made to hold 1,000 centimeter cube of oil. Find the dimensions that will minimize cost of the metal to manufacture them. Find the So this is what we call optimization. If you are an engineer, you have to design them. One of the factors you look at is maximizing quality. So we know that whenever you are solving for a derivative, like you are having a change of one variable to the other, so we can equally apply that principle of how a change of surface will affect cost. But sometimes the relationship become very dependent, so that you know that the bigger your house, the bigger the roof, the bigger the number of sheets you have to buy, the higher the number of how to hire carpenters you have to hire. Also, so many factors. They all depend, right? So we can apply that same. I have my cylinder. Is you realize that in the question we weren't told whether the cylinder was a cylinder or open. If a cylinder is made to hold oil, obviously better that you would assume that this cylinder 1,000. So we've been given the thousands, and you have to find a dimension. Anytime you've been anytime they ask you to find dimension item, like finding right 10 times weight. So we are going to find that will help us minimize. So here the dimension we want to know what we are. If you are dealing with a cube, a box, cuboid, and for weight height. In the case of a cylinder, if you're looking for height, that's I want to find the surface area, right? In optimization, there are two things to look at. Number one, we call it objective function. Objective function. Objective function is a function of focus. This is a function that you optimize. I want to get either the max, or I want to get the but because of the physical limit of or the realities of life, no matter how optimized things may be, cost, volume, or anything that quantity of oil is then shouldn't prevent us from getting it. That is what we call control, right? But I'll tell you that hey, house is not supposed to budget. And budget becomes a factor that no matter how creative you are, wouldn't design a building that will cost more. So constraints are simple. Um, let's say some checks or controls that will prevent over optimization or under optimization. But we need for the optimal. That's why it's called optimal. So now let's get straight to what you have to do. Always constraint is given and it's so simple. That's the first equation. What's the volume of a pi r squared? Right. Pi r squared equal to volume of a. So what do I do? Know that my volume is 1,000. Thousands equal to pi r. What is my objective function? What have I been asked to? The dimensions. Dimensions as I said is derived from the so area is equal to pi r squared h. Oh sorry. Area here we are going to look at the cross. A cylinder has got three cross sections. I have A, I have B, I have C. The two opposite sides, which is a circular cross section, and I have the surface here as my. The area of the two circular sides is equal to 2 times pi r squared, having two circles added together. Then for the smoother surface, is pi r h, right? 2 pi r h times the height. Once you have this done, then optimization, you simply have to make a variable subject and you come and put that the objective function. That is the goal. So that's the way of taking you. So there should be no point where I'll give you a problem. So the goal of optimization, make a variable within your subject, go and put it inside the objective function. Then you optimize. So A is equal to 2 pi r squared. Now let's see. From our constraints, you are having 1,000 equal to pi r squared h. We realize that to make our life easy, better we make r here, we come right. So we make h the subject, get 1,000 over pi r squared. Now I have a variable from my constraint, carrying the constraint side, then we come and put it. have 2 pi r. My constraint is 1000 over pi r squared. That is my height. So once you have this done, fine, you have 2 pi r squared plus this gives us 2000 and r will go 1, pi will go 1. So I have 2000 over r, right? Now we have our objective function fully contains or has been impregnated with our, so we simply have to perform the optimization here. Perform the optimization here means that so the a r should be equal to 0 for us to get the extremes, the critical point. A critical point may be what do you say, maximum. In our situation we are looking out for the, if it happens that we get a single critical point, we're good to, some problems you end up getting several critical points and you have to take the one that will meet. So here when you differentiate r, I get 4 pi r, and this r is the polar negative. So I have negative r minus 1000 over r squared. There, multiply through by r squared, we get 4 pi r cubed minus 2000 equal to 0. 4 pi r cubed equal to 2000. I divide through by 4 away. Then I divide through by 4 pi. I think half my r cubed equal to 2000. So cube roots of 1000 over 4 pi simply gives us those according to our constraint. So, cube of 1000 4 pi, that is 5.42 centimeters. So my radius r is 5.42. Obviously, that's the that we've gotten is a point. But would this be a minimum maximum? For you to know if it's going, but that it's on your second derivative point maximum. Here I'm going to have 12 pi r squared. Is going to be 0. 12 pi r squared, and I put 5.4 inside. I'm going to positive number indicate and refer. So therefore, obviously, 5.4 is a value. Now that I have my r, each was equal to 1000 pi r, 1000 per pi, then 5.42 squared. That is all. We're done. So that is for optimization. Now let's keep on solving some problems here. Okay. So of more, find the volume. Find volume of the solid involving bounded y is y is equal, right? about, so we are to find the volume of the solid formed by revolving a region bounded by two curves about the x-axis. Use equation to find the volume of solid objects which are formed by wrapping this 2D surface about the x. Assuming that I have a shape like um rectangle like this, which is against the x-axis. This is the region. If I revolve this about the x-axis, I'll end up getting solid figure. That solid figure will end up having cross section, right? Like this. This is what I'll get. Good. So this is what we call chain. We can do this revolution simply by integration. That I would break down each cube and I'll break it down into rectangles. I'll find my x and y and sum all of them from this point. That is integration. So how do you find the region formed by the revolution bounded for the washer method? Now, we have Dex method too. Dex method is a straightforward problem. That one have only one function with the x-axis, so there is no hole, so direct. But the question is, what was the volume of any solid figure? We model the volume of the solid figure as something like a cylinder, okay? So we say that volume using integration is pi integral from a to b, our radius as a function of x squared, x is height. Remember that volume is your area times your what? Your height, right? And you can see pi r squared. This whole thing is pi r squared. X, the change in x becomes height within which we are doing application. But in this situation, we have two curves. That's what we call the washer method. The washer method, the two curves, it is only the hole between the two of them for the region that counts. So we have v equal to pi from a to b. I have my r of x all squared minus or r of x all squared x. Meaning that in this situation, I'm going to have two different like the function, functional one will be bigger than the when I take square and I subtract and I out, that will give a volume of it. That's why I said this is called the water method. But the question now here is I have y is equal to square root of x, y equals which one will be bigger? Don't use your eyes to that's why you have done calculus. Calculus after calculus graph f. So when I draw my xy plane, I have y is equal to square root of x, right? So for me to graph this, I need the limit where it starts, where it ends. The second thing I need was the critical point, whether it is maximum. So without even a point, you can just that it is past maximum that will help us. So let's find the limit. First thing, I have y to be equal to square root of x, then y to be equal to x squared. Why don't I equal it? So root x is equal to x squared. Double side, I have x equal to x power 4. X out, s cubed minus 1. I'll have s equals 0, s equals 1. So on my graph, I'll simply come and plot s equals 0, s is equal to 1. From 0 to 1, I plot that. Then I'll ask myself, looking at this function, I want to determine whether it's a maximum of f. So what I do is, I will take my second derivative. It is negative maximum. It is positive, then it's going to be minimum, right? Now that you have our x boundaries, one, what boundaries for y? When x is 0, y is 0. y is 1. So I'll have a point me here, another point me 1, 1 and 0. If for y equals square root of x is the maximum go up, I'll have my y is equal to x squared. 2x going to be, I'll be minus. I'll come simple down here. So the region I'm going to at for going to be about the x-axis. So realize that when I revolve this around the x-axis like this, there'll be a hole, right? There'll be a hole here because this whole thing revolving like that, and there'll be a hole in between. That's why we subtract the radii to get the actual boundary. That is it. So yeah, you've seen that this is bigger than this. So I'm going to have my square root of x minus x squared all squared. The graph form was 1 simple as. So here it cancels. I'll get x becomes x to the power 4 x graph from then becomes x squared out of becomes power 5 out of 5 to 1 inside. I'm gonna get 1 out of 5. 0.4 minus when I put 0 is 0. So this is how we find the volume formed by two circles which have been bounded, which have closed a particular boundary against the x-axis. Now let's see problem. For the next problem, have um okay. So let's do some want you to know before then let's do one roast. Problem says that does f of x equal to x squared minus 4x. Limit point from satisfy. If yes, find first of all what is root. Roster bounded by the rules is derivative of value theorem. If I have any rules is saying that we have so that your functional or your function extreme are the same, or f of a, then it means that so far as your function and it is not a line, there will surely be at least a peak that's from, let's say, one end. Rose is saying that so far as A and B are, then surely there will be a point raised and as far as it's not towards one, at least a point, maybe more, but we add it. So the condition by rooster f of a. So here was our A and f of 0, 0 squared 4 times. I'll give you f of 4, I have 4 squared minus f of 0 Those, how do you find the value of f prime? Pretty about the critical point. Derivative of the function have x to, right? Those for look out for c. So at s equals, that is all. So for Rolle's theorem, it's a point. Let's solve this in s s cos 2x plus 3y is equal to y sine. Find the y, find the y over the x. Find the y over the x. For this, realize that simply do the implicit approach. So what is implicit differentiation? For you to do any implicit, you have to understand the meaning for implicit, and the colleague is called explicit. So an implicit function in our dependent variable is not standing there. As seen, it's not standing there as y is equal to. So if you have any function as y equals to, call this an explicit. By a situation where you have cos x minus the power y equals 0, nothing is taking excess. Solve for any implicit function. Depending on what you've been asked to find, we are looking for y over how y is changing with. Please, every explicit function y. When I give you y is equal to 2x, what happened is when you differentiate y to give times, I change y with respect to what? X. When I came here and I differentiate first, I get 2. I change x with respect to what? X. So this cancel and you get the y. That is what always when I give you y equals this, tell me the y over ds differentiated y by this. So in implicit differentiation, when I have y squared, I'll have 2y by the. You realize that I have x cos of the expression x plus 3y, right? So I'll have x and 2x plus 3y here. Since there are two separate functions, x itself is a cosine 2 plus 3y is a trigonometric function. For that reason, you apply the product rule by this. Product rule means that hold on of this, of this. So for the first thing, let's so let e equal to x, b be equal. Now for u prime, just one. V prime is I want to find the derivative of this equal to x. Function is that it has another function with right of a different variable. For us to succeed, we are going to have it in differentiating with x and equal to y as a the y is from 1. So with respect to x, have when you differentiate, we didn't get to use and remember. So let's say p equal to 2. So the px give me what, right? Now have cos p. When I differentiate cos p with respect to y, I'll get equal to v sine p. What I'm saying, the answer is supposed to be negative sine. You are not done. That is just one part. Plus, when you differentiate the y, have negative, right, sine x. Therefore, my v prime is sine. This one was respect to the y, so the y over plus 3 y dx. So it is fine, right? So I factorize this out here that I'll have. So I factorize that out so that I'll have x plus 3y y over to get 2 plus 3 y over dx. Then you come and do your bigger that truth. It's just the left side of it. So therefore, you're simply going to on the left side we are having x multiplied by the derivative of same, or the derivative is plus 3 dy all multiplying sine plus 0, right? That is when this is not there, and then plus when it is times the original sine of, right, equal to on the side. On the right hand side I have y sine x. For y sine x, what I get, I'm going to get simply the y is going to put the y dx y x, then plus sine of. So have this nicely done here. Then make the y dx the subject. Make the y subject. That means that I will have to expand this back again. That will be 2x plus 3x y dx multiplying sine of the equal to, no, plus my cosine of 2 plus 3y equal to the y over plus cos x. So once I have this, I only have to make y dx subject, right? Y dx subject. I make it. Okay. So I'll have x minus cos x plus I'll have cosine of this x plus y, right? X plus 3. Okay. Yeah, so I think I didn't do the right side well because I was supposed to just do it for product rule and I did for one. I think for the y side, after the equal to sign here, it is y sine x, right? Y sine x. So y is an independent variable from x. So when you differentiate y, it's y dx, right? Then you have your sine x plus when you maintain y and sine x, you get what's called. So this is what I was supposed to have done, right? So the same thing here. So I'll introduce x here, comes cos x, then I introduce y here. So when I'm doing my subtraction, I'll simply have to do the right grouping. So 2x outside here, right? Go from that 2x. So remember that this is multiplying everything. So 2x multiplying sine x plus 3 like this, plus 3x multiplying sine 2x plus 3 y dx, plus cosine of 2x plus 3y equal to sine x y x plus y cos like this. So this and this are my dy and dx. I can push it, right? So 3x sine x plus 3 y dx minus sine x y dx equal to y cos x minus cosine of 2x plus 3y minus 2x sine 2x plus 3. It's crazy, right? Yeah, so that is the nature of this problem. Take y the subject, so dy over dx, open bracket 3x sine x plus 3 minus x equal to y cosine 2 plus 3y minus 2x sine x plus 3y divide all of x sine 2x plus 3 minus sine x 3x sine x plus 3. That is all. So um I would like to end here and I'll see you another time for of problem for us to look through. I have a couple of. So thank you so much for being with us this tutorials, and please any question put it in the comment section. Okay, anything that you would like to ask or you would like to be added, then do also subscribe. Make sure you share to your friends. Also rewatch if you didn't get any problem. And actually I think the last one bit of issue. So I'll see you. Thank you.